All right, welcome to the Explainer. Today, we are popping the hood on your office network. We're going to act like mechanics for a bit, but, instead of pistons and oil, we're tracing the invisible flow of data and power inside those blinking boxes to figure out what's absolutely driving your connectivity. So let's start with a really common question. Do all those blinking network boxes on your desk actually do the exact same job? I mean, if you've ever set up a network, you've seen them sitting side by side, right? Just identical, rectangular metal boxes filled with Ethernet ports and a tangled mess of cables. But assuming they perform the exact same function is a huge and potentially network-crippling mistake. It is so easy to look at a rack of gear and just assume it's all generic internet stuff, but the reality is actually way more intricate. Here's our roadmap for today. We'll start with the network hardware puzzle, move on to hubs and passive data broadcasting, dive into switches and intelligent traffic control, step out to the internet with routers, and finally unpack modern gateways and PoE technology. It's a full evolutionary journey from the oldest networking headaches all the way to some really sleek modern solutions. Okay, section 1, the network hardware puzzle. Why does solving this puzzle and choosing the right box actually matter for your daily digital experience? Well, because we shouldn't just grab the first device with flashing lights off the shelf. Choosing the wrong equipment isn't just a minor IT headache. A hardware mismatch can literally bottleneck your network, giving you slower speeds and completely wasted bandwidth. Worse, it can open up massive security vulnerabilities, turning a private file transfer into something anyone can intercept. Or, it could leave you entirely stranded with a complete inability to reach the internet. It's basically the difference between cruising on a high-speed expressway and being stuck in a constant digital traffic jam. But before we crack open our first device, we've got to set the boundaries of our local area network, or LAN. Think of this as your internal battleground. It's the physical space where your local devices, your desktop computers, your laptops, your printers, are physically connected together. It's a closed ecosystem. Keep this local environment in mind as we look at how different pieces of hardware try to manage the traffic flowing around inside it. Moving right along to Section 2, Hubs and Passive Data Broadcasting. Let's look at the industry's oldest, simplest attempt to connect these LAN devices together. Enter the network hub. And here's the thing about a hub. It is not intelligent at all. It cannot filter data. If one computer sends a private file, the hub blindly duplicates those incoming data packets and just broadcasts that data to every single connected port. It's literally like using a megaphone in a crowded room just to whisper a secret to one person. Obviously, this wastes an incredible amount of bandwidth and creates massive security risks because anyone on the network can snoop on that data. Now, there are a couple of types: passive hubs that just pass the signal along without power, and active ones that require power to amplify the signal. But honestly, these fundamental flaws are exactly why hubs are practically obsolete today. Which brings us to Section 3, switches and intelligent traffic control. To fix the absolute nightmare of collisions and security risks caused by hubs, network engineers stepped up their game. But to understand how this new device works, we actually need to define something called a MAC address first. Think of a MAC address as a permanent digital fingerprint. It's a unique 6-byte hexadecimal physical identifier that is burned directly into a device's network card by the manufacturer. Fun fact, no two devices on Earth share the same MAC address. That makes it the absolute perfect tool for identifying exactly who is who on a local network. And this brings us to a really beautiful comparison: hubs versus switches. While the dumb hub operates like a screaming town crier, duplicating packets to all ports and wasting bandwidth, the switch is an intelligent device. It actually reads those incoming MAC addresses to target specific ports. It dynamically builds an internal memory map, delivering data strictly to its intended target. The rest of the network stays totally silent, highly secure, and incredibly fast. It's a real game changer. All right, Section 4, routers, the internet gateway. So we've mastered traffic inside the local network, but what happens when your local devices need to talk to a server halfway across the world? To leave the local area network, we have to shift our thinking from physical to logical, and that means using an IP address. An IP address is a logical 32-bit numeric address. You've probably seen something like 192.168.1.1 before. This address identifies exactly where a device sits within a much broader network. Basically, it gives the global internet the coordinates needed to route data to your specific location. So here is the absolutely crucial distinction you need to take away from this. A MAC address is a physical, permanent 6-byte hardware identifier used strictly for local LAN traffic. An IP address, on the other hand, is a logical 32-bit numeric identifier used for routing data across completely independent networks around the globe. To put it super simply, switches use MACs to navigate the office, routers use IPs to navigate the world. And this dynamic creates an incredible security checkpoint at the router. It's a simple three-step process. First, a data packet arrives at the router. Second, the router inspects that destination IP address. And third, the router makes a critical decision. It either keeps the packet safely internal, or it routes it out to the external internet. It beautifully isolates your local traffic from the chaos of the global web. It is the ultimate gatekeeper. Okay, on to our final stop, Section 5, Gateways and PoE Technology. Let's see how all these separate evolutionary pieces come together in the gear we actually use every day. Now, you might be thinking, hey, I don't have separate hubs and switches and routers cluttering up my desk at home. And you'd be right. That plastic box your internet service provider gave you is a modern all-in-one gateway. It elegantly crams 4 separate systems into one chassis: a broadband modem to connect to the ISP, a multi-port switch for your wired Ethernet connections, a wireless access point to manage your Wi-Fi, and an IP router to translate public IP addresses for web access. It's the whole shebang in one box. But as our networks have evolved, so have our power requirements. Enter PoE, or Power over Ethernet. This technology is absolutely brilliant. It delivers both network data and electrical power through a single standard RJ45 Ethernet cable using everyday UTP twisted pair wiring. And it does this without the electrical voltage causing any interference to your data streams whatsoever. The real-world impact of PoE is just massive cost savings and convenience. It entirely eliminates the need to hire electricians to run extra high-voltage electrical outlets up near the ceiling. You can perfectly power your security IP cameras, your wireless access points, and your VoIP desk phones using just that one single data cable plugged into your network rack. It keeps modern networking setups incredibly clean and highly scalable. So, as we wrap up this explainer, I want to leave you with a quick thought. Now that you actually know how your data flows under the hood, is your home network acting as a smart, secure gateway? Or is there some ancient, passive hub lurking in your setup just wasting your bandwidth? Think about that the next time you glance at those blinking lights on your desk. Thanks so much for exploring this with me, and I really hope this empowers you to build faster, more secure networks.